My name is Stephen from Richford Graduate Institute of Technology. I do research in neural networks. My background is computer science. So I do research in optimization and neural networks. So when I saw the core, I thought it was a great opportunity for me to apply this solution to solve the problem, the real-life problem, on malware detection. So this is a paper that we developed with Dr. Kubrar. Dr. Kubrar is not here, sorry, but I have my colleague, Mr. Ivan Naido there. So the title is Unintelligent Malware Detection Using a Neural Network Ensemble Based on a Hybrid Search Mechanism. So in the paper, we tried to solve the problem of malware detection by building a model. So we created an intelligent model, and our intelligent will mean that it's autonomous. It autonomously detects malware, especially in dynamic environments, non-stationary environments, where the location is changing, the nature of malware is changing, the solution is changing. So the model, it keeps track of the changing landscape and identifies that problem, that solution. So we shall see how that works. So just to give you a context, so I'll be brief. I'll give you the context, then touch on the methodology, and then give you the results. So malware here, just to make a clarification. So malware here, I mean, it's just an umbrella term that I use to get all the harmful software. I just use the word malware to combine all the malicious software. So I'm not just honing in on a specific type of software. So the definition is, it is a malicious software intentionally deployed to intrude computing environment by exploiting vulnerabilities. Now, there are different techniques that people use, that these criminals use. For example, code obfuscation and also malware modification. So these are some of the techniques that they use to thwart detection. So these are some of the different malware that we have. I'm sure you're familiar with these types of malware. You see, for example, like rootkits. Rootkits, that's a collection of malicious software that is designed to get unauthorized access to different systems. So this is a very difficult malware to track. So even when you're developing the solution, rootkits, they are really complicated because it's a collection of different types of malware. So in building this solution, it's very important that you understand the context and different ways of classifying malware. For example, in terms of the delivery, what's the attack methodology, for example, phishing, then the specific type of vulnerability that the malware is exploiting, like SQL injection, domain spoofing, and so on. So you need to understand. Then also the goal, like for example, ransomware, which had the financial goal, and then others are based on the platform, like mobile, they attack on the mobile devices, and so on and so forth. Then maybe the way they conceal themselves, approach stealth, and also the specific area. So these ones, they are very important when you're building your solutions. So I'm not going to go into this because of you can read this in the paper. So, but it also gives a context to understand the development of malware, how it came about, and you look at the patterns, so that fits into your solution as well. But malware has its origins in the publication of John von Neumann in his lecture theories in 1949, where later in 1966 a paper was developed called the Theory of Self-Reproducing Automata, based on lecture theories of John von Neumann. And in that paper, his theories, he explains that the mechanical organism, like a piece of code, it can be used to replicate itself automatically. So that's really the basis of what we see today. And then Risak, in 1972, he built on the ideas of John and describes a form of a virus that was written in assembler language for Siemens computer systems. And then in 1980, Cross built on that, and this was actually a thesis, which was titled Self-Reproduction of Programs. And in that thesis, Cross postulated that computer programs can have like biological viruses. And then, of course, in 1984, we saw the first computer virus there, and then the creeper virus was detected first on ARPANET, which was the forerunner of the internet, and it infected like 10 computers. So that was the first virus, creeper. And then Reaper was developed to delete the creeper. That was like the first antivirus. So then from there, then we saw the explosion of malware. It exploded due to the internet, and of course the Internet of Things. For example, in 2000, there were more than 50,000 viruses, and then 2008, Symantec detected more than 1 million viruses. And then in 2010, and I think the year 2010 was not good for cybersecurity, because 60 million, you can imagine from 1 million, 60 million viruses, pieces of malware were detected. So that's when we saw nations launching digital attacks against their enemies, hacktivists disrupting the internet as a form of political protests. So then malware exploded, and so on and so forth. And then also the MageCat. Who knows what MageCat is? Anyone? Yeah, so MageCat, this is a credit card stealing software, which has been infecting e-commerce websites since 2014. And in fact, in 2018, it came to a head where all the multiple large-scale online retailers were infected, including the British Airways. So the cyber attack hackers, they implant the malicious computer code into the websites. So at the checkout, this piece of software, it steals all the information of the users. And then this is, I extracted this from the Kaspersky report, where it gives an interesting perspective. They looked in 24 hours from 10th to 11th May. So they showed users the local infections that took part in 24 hours between 10th and 11th May. And so I found this very interesting. And in fact, Symantec, recently they also announced that it had blocked more than 1 million attempts to implant the digital card schemas on more than 10,000 unique websites. So then we looked at the different, we reviewed, of course, the related research to see some of the solutions that have been advanced and to situate our work in the relevant body of knowledge. But I'm not going to go into this. I'll just give you the finding, the key highlight, the finding from the literature. So although these approaches represent state-of-the-art advances, despite all the advances in building solutions to the problem that we have, the malware problem landscape continuously evolves at exponential speed. And this was echoed at the World Economic Forum last year as well. So the solutions that we have currently, they can't keep up with the complexity and the dynamic nature of the current malware.
You have 3 minutes.
So then we modeled the problem in different ways. So the first way is really looking at the malware detection as a combinatorial optimization program. Now, this is very important because in computer science, there are 2 classes of programs. You have P or NP. So P, that's really like solving a basic problem, like adding 2 numbers. You can solve that in a polynomial time. But there are those problems that you cannot solve in the polynomial time. You only need an algorithm just to verify that the solution is correct. So it's very important that we, based on the big data and the current situation now, it's important that all the solutions for malware detection should be modeled as NP-hard programs to minimize the error and also the time in finding those solutions. So we built a neural network. Neural network, that's just a set of algorithms modeled after the human brain. So the neural network, it was based on it's a learning, so we applied it on a set of data to learn data, and then we applied it on a program based on its experience on the data that we use. So there were 2 approaches. The first one is the feed-forward. The feed-forward approach. That's where learning is performed in a forward sequential format. Like, for example, you have inputs, you have the activation function, which basically defines the output of the neuron given the input or the set of inputs that you have. And that's the mapping. Or the back propagation, where you reverse the procedure and you compare the outputs with the expected output. So this really encapsulates the whole research that was done in the paper. So blending individual neural networks to create capacity for generalization, to minimize error, and to reduce variance. So we combine different neural networks and then apply them on a set of data. The data had both malware and benign types of data. So the algorithm was able to detect malware from the data, the sample data that we applied. Okay, so of course you can find all these methods, the functions that we used in the paper, and then so this is the methodology that we use. So we used memetic algorithm. So I know most of you are familiar with genetic algorithm. It's being used a lot in solving problems, but MA or memetic algorithm is more efficient than genetic algorithm because it does the local search optimization. And it mimics the cultural environment instead of, rather than just the natural evolution of genes on which genetic algorithm is based on. So memetic algorithm is able to look at all those different aspects. So we created a program. So the coding, this was just the iteration. Now the important aspect is here. This is the differentiating factor. Applying the local search, applying the local search helps to prevent premature convergence of the program. So you apply the local search, it searches the neighborhood of the solution to get better solutions, right? So this is very important. And then you evaluate fitness. If the solution is better than the existing one, you replace the solution. If it's not, you keep that solution. You add just the operator. So that is the memetic algorithm operators. You have the mutation, recombination, and others. And then, so that is the one procedure. Now, on the local search, we use the technique called the Tabu Search procedure. This one is very important. It is a meta-heuristic optimization technique.
Now over time.
Okay, so results.
Sorry about this.
Okay, so this is the last one. I have only 2 slides. So on the results, so we loaded the neural net library into the R platform. So we benchmarked our algorithm on the existing methods. So first of all, we implemented a neural network ensemble with the genetic algorithm. So we embedded genetic algorithm in the neural network ensemble, implemented that in R using R programming, and then did the SEO. SEO, that is anti-colony optimization. It is really based on the capability of ants to find the shortest path from the nest to the food source. And then we also tested it on the PSO, that's the particle swarm optimization, which is based on the behavior of birds. So the way birds flock together, so that algorithm is based on the behavior of the physical movement of birds to avoid predators and how they seek food and so on and so forth. So we benchmarked on that. So for the SEO, for example, I extracted this from one of my papers which was published in the Journal of Applied Mathematics, where I applied the SEO to find to solve the traveling salesman problem. So that one is also relevant there. So the results, so from the synergy of memetic algorithms and neural networks in all the iterations, so the search was able to converge to the solution faster due to less variance, of course, but also it increased the convergence strength as clearly demonstrated in the paper. Then, of course,
I'm going to have to ask you to stop there. I'm really sorry, but I can see you've still got a lot to share.
Okay.
And maybe you just want to make a closing statement.
So the closing statement, conclusion, we prove our hypothesis that the neural network ensemble, based on a hybrid search mechanism, is really an efficient way of detecting dynamic and complex malware, especially in today's age of big data. And the local search procedure, where we apply the Tabu Search, it helps to minimize error, which increases accuracy as a result of the local search improvements. So this is a real solution for a real problem. So we solve a problem using and we experimented this, we applied it, we got results, and so if some of the industry people, you can apply this to solve your problems that you have with regards to that. Thank you so much.